Good evening, geometry students. So today we are continuing in our notes for chapter 2 and we're doing section 2-5. And this has been a chapter all about reasoning and logic, and it's all leading towards something called proofs, which will be in your next section. But so far, we've talked about inductive reasoning and deductive reasoning. Now we're going to go even more focused into reasoning in algebra and geometry. So now we're talking about mathematical reasoning. And a lot of this is based off of properties and laws and postulates and things like that. Things that we know to be true or take to be true. So we're going to be talking a lot of mathematical properties today and how we use them to reason through problems and solve them. So our learning target is I can determine when a property of equality or congruence is being used, and I can justify steps in solving equations. So it's all about how do you get from one point to the next. So we have a lot of properties that we need to cover, and let's jump right into it. The first thing that we're going to talk about is the reflexive property. The reflexive property in symbols is A equals A. In other words, some number equals that same number. The reflexive property is the same on both sides. So it might look like x plus 3 equals x plus 3, or 2 equals 2, and so on and so forth. Next, we have something called the symmetric property. And here it says, if some number A equals B, then you can flip the order around and B is equal to A. So you can swap the order and it's the same. So I'm going to write that over here to the side. Swap order, or the sides. And it's an equivalent statement. Moving right along, now we're in something called the transitive property. So transitive, this is going to be kind of, I think about how the variable almost travels through the equations, because we are going to say that two things are equal to each other. So then we're going to say that the first and the last must be equal to each other as well. What I mean by that is this. So let's say if A equals B, so some number A equals B, and B equals C. So now we know A equals B and B equals C. Then we can then eliminate this B and go straight to, well, A must equal C then. It's very similar to the law of syllogism. You might be noticing that, but it's not quite the same because this is complete equality while a syllogism still leads from one thing to the next. So I kind of think of it as you can kind of travel through the equations. That's just a way that I kind of make sense of it in general terms, so to speak. These next properties you should have heard of before. We have the substitution property. You guys have been using this a lot for many years probably when you've been studying math. So the substitution property is if A equals B, so some number A is equal to some number B, they're the same number or the same value, then B can replace A in an expression. So this is very similar to when we solve for a value x and then we take that number that we calculated and we put it back into the equation. So this is similar to that, substitution. Next we have the distributive property. Pretty much everybody's familiar with that. We've been doing it in our DMR for this unit. And the distributive property is if you take a number, say A, and you multiply it across a parentheses, say B plus C, then you get a times b plus a times c. But something that's important to note is this also works with subtraction. So right here we have addition, but we can also do it with subtraction. So I'm going to say a multiplied by b minus c is going to be ab minus ac. Continuing right along, we also have the addition property of equality. Now, you might not be constantly thinking in these terms, but you use the addition property of equality very, very often. Honestly, I would say the majority of algebra problems, you're using some type of property of equality. This is the rule of do the same thing to both sides of the equation. So now we're just getting down into their technical terms. The addition property is this. If a equals b, so we have two sides of the equation that are balanced, then a plus c is equal to b plus c. I can add the same amount to both sides of the equation and get an equivalent equation. So this is when you are adding the same, that's important, same amount to both sides of an equation. So you probably guessed it for the rest of our definitions now. For our subtraction property, our multiplication property, and our division property, all of these, as long as you do the same thing to both sides of the equation, then we're going to get a balanced equation as a result. So subtraction property, if a equals b, then a minus c is equal to b minus c. Once again, this time we're just subtracting the same number from both sides of the equation. Multiplication property, if a equals b, then a times c is equal to b times c. Division property, if a equals b, then a divided by c is equal to b divided by c. Something that people sometimes forget, a fraction bar is a division symbol as well. So fraction just means divide. What I want you to notice here, with all of these properties real fast, from transitive on, we had an if, then, if, then, if, then. So if one thing, then the next. Just like with the addition property, if a equals b, then you can do this. So it's kind of like a dual step process almost. You need multiple pieces of the puzzle to be able to see the whole property in action, is what I'm getting at. Okay. The last one, it says CLT, and this just means combine like terms. So this is something that we're allowed to do in mathematics. So for an example, a plus a is equal to 2a. Remember, like terms need to have the same variable in the same exponents as well. Alrighty. Now that we've covered all of those properties, let's start kind of identifying some and looking at some examples. That's the majority of what our notes are today, just practicing and getting our vocabulary all taken care of. So here it says, name the property that justifies each step. So justifies means, how are you going to support your work? What is your reasoning? Prove to me that you know why you're allowed to do this. And we're going to do that with the properties that we just defined. So here it says, if x equals y and y plus 4 equals 3x, then x plus 4 equals 3x. So what you should be noticing here, the change happened where the y was replaced with the x. Now, because there's a replacement, then we can say, oh, this is substitution, and we were told x equals y here, so we are going to say this is the substitution property. I'll just abbreviate it like that. Okay, in example B, it says, if x plus 4 equals 3x, then 4 equals 2x. Here you're looking to see, how did I get from B to the next part? Well, we subtracted an x from the left and we subtracted an x from the right. So notice there's no x over here anymore, and there's only 2 x's on the right side now. So clearly an x has been taken away from the left and right sides of the equation. Because we subtracted the same thing from both sides of the equation, this is going to be the subtraction property of equality. Okay. For letter C, it says angle P is congruent to angle Q. Angle Q is congruent to angle R. And angle R is congruent to angle S. Then P is congruent to S. So notice how this angle P kind of travels through the statements. So P is congruent to Q and Q is congruent to R. Oh, well, that must mean P and R are congruent. But then R is congruent to S, so that means P and S must be congruent. So this is going to be the transitive property. Here we have angle QRS is congruent to angle QRS. When it is exactly the same on the left and right side, like nothing is different at all, it says the same thing on the left and right side of the equation, it is the reflexive property. Here we have measure of angle 1 is equal to the measure of angle 2, so the measure of angle 2 equals the measure of angle 1. The only difference to get from one spot to the next is we took the sides of our equations and we flipped them backwards. So our solution is going to be the symmetric property. And when you're like working through examples of this, if you need to keep your notes beside you because you're still learning the vocabulary, then you're more than welcome to do that, because this list that we just did on the front side of these notes, this is going to be really helpful to get you used to these terms, because some of them you might not be quite as familiar with. Many you will be, but some maybe not so much. Next it says, if 3PQ is equal to 45, then PQ is equal to 15. Well, how did I get from 3PQ equals 45 to this one, PQ equals 15? Notice how I got rid of a factor of 3. Well, to get rid of a factor of 3, then you actually divide by 3 on both sides. So now this is going to be the division property of equality. Alrighty. So that was all of example 1, all of those little subparts, just labeling and identifying examples. Now we're going to do this again. The only difference is this time we are going to be progressing through a problem. So this example is very similar to what you're going to eventually be doing when you have proofs. So you start with one step and then you're working the same problem one teeny tiny baby step at a time, justifying your work as you go. So here is our original. So I'll just write that right here. This is our original problem. And then we ask ourselves, how did I get from this step to this step? What did I do? Well, notice how on the left side it says only 5x. There's not a minus 12 anymore. So they must have added 12 to the left and right sides to get 5x is equal to 44 plus x. So now I'm going to say that step, what I did in this was the addition property of equality. It's addition because I added 12 to both sides to get to the next part of the problem. After that, it says 4x is equal to 44. So how did I get to 4x? And how did I get rid of the x on the right side? I subtracted x from the left and right. So that was the step that they did. So you're not going to say subtract x. Instead, you're going to say the property that you used to apply this subtraction of x. So that is the subtraction property of equality. Now we're down to our very last step, and notice the factor of 4 went away in both of these. So you divided by 4, and this is going to be the division property of equality. Okay, so these notes did take up a little bit of space, so we are now going on to another page of notes, but this is the last one, so stick with me, everybody. And it's not even a full page, so we should be able to get this taken care of within the next couple minutes. Alrighty. So now we're writing a justification for each step, and here is our image that we're basing these steps on. First, we have NO is equal to NM plus MO. This is no longer just an original problem. We derived this problem from the picture. Well, remember, when you take two smaller parts of a segment and then you add them up to get the total, that is a postulate, and it is called the segment addition postulate. Okay. So that was our first step. We had to set up an equation based off of the geometry shapes or image that we see here. Now they went from NO to 4x minus 4. They went from NM to 2x and from MO to 3x minus 9. What you should be noticing, NO all the way across is equal to 4x minus 4. And NM from here to here is equal to 2x. And MO likewise for 3x minus 9. So here we're replacing the geometric term for the value with the algebraic expression. So here we are substituting in an equivalent expression. So this is substitution property. Now we're going to be able to move along a little bit quicker. These were the two hard steps, and you guys will probably have it from here on out. So to get up to our next one, notice they combined 2x and 3x. So this is going to be combining like terms. Then we have to ask ourselves, how did they get to negative 4 is equal to x minus 9? Well, notice there's no x terms on the left, so ideally we would notice, hey, they subtracted 4x from both sides, so this is going to be the subtraction property of equality. And finally, we have it down to 5 is equal to x. Well, notice we added the 9 to both sides of the equation, so if you add 9 to the left and right sides, then this is going to get positive 5 is equal to x. So that will be the addition property of equality. Okay, so that's the last example where we have to identify what we're given. Now we're going to have to make our own examples. And I don't want you to overthink this. We're doing more and more problems like this during class time practice where I'm expecting you to come up with your own original example. So don't think that it has to be anything intricate. Just, as long as it follows the rules of the property, you're fine. So here it says reflexive property. We need the same exact thing on the left side as we have on the right side. So it can literally be as simple as this. 0 is equal to 0. It's the same on the left and right side. If you want to get a little bit crazier, you can say negative, 5 5 square root 3 is equal to negative 5 square root 3. Same thing, left and right sides for both of these. Next, we have the addition property of equality. Remember, we need an if-then. So we say if and whatever you want. So we can say, I don't know, 2x minus 3 is equal to 9. And then what would we add to both sides of the equation? So if this, then 2x is equal to 12. I added 3 to both sides of the equation. But it can be simpler than that. You could say if 2 equals 2, then 2 plus 1 is equal to 2 plus 1. I added the same number to both sides, and it's okay. Next, we have the transitive property. So I'm going to do this with measures of angles this time, just so you can see some of that, some of those symbols a little bit more. So let's say that we have the measure of angle Q is equal to the measure of angle M. Now I need this angle M to equal something as well. So measure of angle M is going to equal measure of angle Z. So this is if. This is all of my original work. So now I'm going to say if all that works, then Q must equal Z. For our very last one, we have the distributive property. You guys do this all the time, so it might look like this. If negative 3 is multiplied by x minus y, then that's going to equal negative 3x plus 3y. And there you have it. Now, just keep in mind that I am going to be asking you to give me some of your own original examples of these, so it might be ideal for you to go ahead and write some of them down to prepare for class in the future. But until then, if you have questions, bring them to me when we're in school, and I hope you have a good night.